Now let's look at a concept called molecular polarity. So we can have polar bonds within a molecule, right? And you have you have uh, you have these bonds that are facing in opposite direction. For example, look at carbon dioxide. Carbon dioxide has polar bonds because the electrons are not evenly shared between oxygen and carbon. But guess what? That happens in both direction. Okay. So it's not evenly shared in this direction, it's not evenly shared in this direction. Look at the direction of the arrows. So because the polarity or the polar bonds all pull in opposite direction, the carbon dioxide molecule will tend to be a non-polar molecule because what we describe here is that the polarity cancel out. So just imagine two people pulling in opposite direction. So they have the same strength, but they are pulling in opposite direction. Okay. So this is going to cancel out. Okay. Then the polarity cancel out and the molecule will not be polar. That's one thing I want you guys to take note of. The polarity will not exist. Okay. All right. Now that is carbon dioxide, but let's look at water. If you look at the water molecule, you realize that the polarity in this case are pointing in both directions. So for that reason, the water molecule is polar because the polarity point in the same direction and not opposite direction. So it doesn't cancel out in a water molecule. So water molecule is polar while carbon dioxide is not polar. Okay. So what happens is when so many water molecules come together, when they come together, what happens is the direction in which the electrons are pointing always makes that direction more negative. For example, the electrons are pulled by oxygen, and so oxygen is going to have a negative center. As you can see here, there's a negative center. While the electrons are pulled away, when electrons are pulled away from an end, that end is going to be what? Going to have a positive. So when so many water molecules come together, what happens is that the positive and the negative ends will be have the tendency to come towards one another. So this water molecule will arrange themselves in such a way that the negative end of one molecule is attracted to the positive end of the other molecule. And so that is how billions and trillions and sextrillion of carbon atoms or water molecules come together. Okay. Now, water has such a relative high boiling point because the molecules are so sticky. So they are polar and so they stick to one another. That's why to separate them, it takes a lot of heat. And that's why water has a high boiling point because of that stickiness that exists between them. Okay. So now when we talk about what we call ion dipole, the attraction between an ion and a dipole. So we take an example of water. When you put salt in water, what happens is that this salt is going to separate into its ion, for example, sodium chloride. So sodium is going to exist as sodium plus, while chlorine will exist as Cl minus. And so what happens is that the positive end of sodium is going to be attracted to the negative end of water. Okay. While the negative end of chlorine is going to be attracted to the positive end of water. So that's what we call ion dipole. Okay. That's exactly what happens when you put salt into water. you will have an ion dipole that is going to be created. Now, the attraction between two dipoles is what we call a dipole-dipole attraction. Example are the cohesive forces within water. So the ability of one water molecule to be attracted by another water molecule, right? It's what we call ion. It's what we call a cohesive force or ion or dipole-dipole. So you can have an ion dipole, which is the attraction between an ion and a dipole in a molecule, or you can have a dipole-dipole, which is the attraction between two molecules, or you can have an induced dipole. Okay, so these are terms that we will only go deep into them when we do chemistry and when we do college chemistry. Okay. So you just have to know that when we talk about dipole, it's because we have charges that are being separated or because we have uneven distribution of electrons. Okay. So is it possible for a fish to drown? For the questions, right? Yes. When the water content contains too little oxygen. So when the water contains too little oxygen, fish don't breathe water. Their gills extract small amount of dissolved oxygen which can be found even in water that remains still. Okay. A non-polar material such as oxygen is soluble in polar material such as water by way of what? It's going to be by way of dipole and induced dipole. So water that is polar is going to induce a dipole in oxygen that is non-polar. Okay. Now, you have a fourth molecular attraction is the induced dipole, which occurs between non-polar molecule. So induced dipole is a dipole that is created temporarily. Okay. And so non-polar atoms are attracted to each other by these momentary dipoles. All right, the larger atoms, the stronger the momentary dipole. Okay. So the tiny polar fluorine atoms within Teflon, okay, provide very weak attraction, which is why Teflon provides a non-sticky surface. So how do the gecko sticky feet stay so clean? Which type of molecular attraction takes the least amount of energy to break? The induced dipole. Okay. All right. So that's that for this section, and I will see you in the next chapter.